Okay, so we're meeting today. We're going to have a look at the latest developments around device telemetry and our moves towards offering service assurance with our existing monitoring capabilities. This will cover the ESRI dashboard as well as a few items that we've been working on internally and looking a bit at the roadmap as well in terms of how these things can align and help support each other going forwards. So let's start by talking a little bit about telemetry and service assurance. So for a while now, ETI has had the ability to collect telemetry from a wide variety of network equipment. So wherever we've been talking about things like NETCONF and gNMI, these are protocols that are letting us go out and talk to various bits of equipment from all sorts of different vendors and bring them back into a centralized data store. So you've got all of that information about how well different pieces of equipment within a network are performing. As part of that kind of first round of adding that telemetry capability, we added a whole bunch of dashboards into our stack, which allowed you to go in, visualize that data, and get an idea of how well things are performing. But this was all very telemetry focused, which left us with a problem. So telemetry is very useful and it's a critical foundation that that will get you to service assurance, but it is not service assurance in itself. You actually need to do some stuff with that data. So what is service assurance? Well, it allows us to take all of the stuff that we're collecting, a lot of the things that we're generating from that data, so be it events or alarms, different things that we have within that sort of dashboard set, and actually make it into actionable items, things that people can go deal with, so that they can understand the impact of an issue, whether it's something isolated, whether it's something widespread, whether there's an upstream cause of an issue. All of these types of scenarios are kind of key to actually get to that service assurance category. So we want to provide a tool set that's going to allow people to find issues, understand what is causing them, how big those issues are, so they can start taking quick actions to go and remedy those problems and understand what kind of action would be required to remedy those things. So that leads us on to the kind of latest developments that we've been doing. So a big focus today will be having a look at the ESRI integration that we've been working on. So this is taking that telemetry data that we're collecting and giving it some context and tying it to other useful pieces of information that are going to help towards those service assurance goals. So that's going to be things like putting all of the telemetry that we're getting into locations on a map, so you know where those issues are occurring, where things are, and how they're doing in their particular locations. But we'll also be able to layer in other critical data that's going to give context to all that telemetry that we're getting. So key one that we're going to see in the demo today is linking that to a fiber network, so a full fiber network build out plan. So when we're providing that telemetry data, if you're just looking at raw data, it's not going to tell you something like that a fiber has been cut and that is causing all of these downstream issues. But viewing these things in a geographic context where you can see those fibers that are going out to certain sites and certain locations, and also being able to overlay things like 811 data, which is like construction information, so we can put over all of this information where people are out digging holes in the ground that may, cut fibers or break other connectivity, communications, power, anything else like that. All of this can be overlaid and used to add context to what we're showing in terms of all that telemetry information. It'll also allow us to put things into wider context as well. So rather than just looking at an individual piece of equipment and how well it's performing, we can start to aggregate that up to different levels so that we can understand how one service territory is performing against a different one. There may be different factors there, right? You may have different vendor equipment in those different sites. You may be offering different technologies in those places. So you can begin to infer a lot more about what that telemetry means in the context of your wider network. Another parallel effort that we've been working on is our own kind of visualization tool as well. This is going to help to understand the interdependencies of things, so what is connected to what and what impact that might have. And critically, it's going to do its own kind of issue identification, go look for problems and flag those problems up to the user and suggest things like the root cause of that particular problem. Okay, let's get on to why do we do this, right? What is the value to a service provider, to a potential customer, of providing all of this service assurance capability? So as I've touched on already, it's really down to quickly identifying problems as soon as they happen, or ideally before they happen. So looking for things that are degrading in the network, looking for where performance is starting to drop, so you can take action before you get things like an actual outage or the kind of deep degradation that would cause a customer to phone up and complain about their service. We're going to be providing kind of much better visibility of what's going on. Like I mentioned before, we had those dashboards and things which were effective, particularly for looking at individual devices. But this is all about understanding that kind of wide network impact, how things may impact on multiple customers at a time, and letting you know where those kind of upstream breakpoints are and what those downstream effects may be. So we're looking to kind of generally improve the operations of an ISP, their support processes, and evolve this through into more of a kind of quality of service and understanding, is a customer receiving the level of connection that they expect, or are there other issues that need to be addressed to get them to the right point and make sure that they're going to remain a happy paying customer for the service that you're providing? All of this is going to be based upon kind of very standard protocols and technologies, and even the ways that we kind of store the data and use the data. All of these are using very sort of open, publicly documented processes. So it allows us to hook into many different things, as we'll see as we get into certain parts of the demo. This is not just applicable to a fiber network or one very specific type of thing that an ISP may want to monitor. Really, any of these sort of interconnected systems that they may have, they can monitor in the same way and look for the same sorts of issues as well. All right, and just before I jump into the screens, just to give you an idea of where we're going with all of this. So as mentioned, we've got that sort of issue identification processes that we've got going on that we're doing ourselves with the data. A very short step from there will be to provide those insights via API as well through the user interfaces that we're providing, which means that not only will we have that information, but in a scenario where we're doing things like the ESRI integration, we can provide those same sorts of insights to that view there as well. So we can have all of this sort of analysis going on local to where the data is being collected, but where a user is in looking at a network, be it on a geographic map or wherever it may be, they can pull in those kind of insights that we're generating on the data. Now, the things that we've been working on, we do have some kind of AI integrations going on in there, but it's fairly basic right now. What we want to do is sort of keep expanding that AI usage in the system. So be it on the kind of issue and concern analysis side, we can bring in AI on that side. And use it to kind of work out what's going on, not just have that in sort of fairly linear kind of code paths where we're trying to, do a bit of working out on things, but we can hand these things off, hand the data that we've got off to an AI, and let it try and figure out the issues that are in there and present those issues to the user, or again through the API as well. Then another key next step, as well as kind of what we're doing now in terms of finding those issues, trying to find root cause of those issues, we want to be able to provide kind of recommended actions to a user, right? So is this something that you just need to go and reboot a device for, or is this something that needs like a field tech to go out and do something, which takes us one step further in that sort of service assurance path to make sure that we're providing actionable insights with clear next steps and clear actions. That can then also lead on to other kind of AI integrations. So we've got things like agentic AI, so an AI that you can give a specific job and get it to go and do it. Then the kind of recommended actions that we're creating, we can then feed to those AIs. So in certain safe cases, if it is go and reboot a device, for example, it's not a user having to log into something and go and do that action, but we could actually hand that kind of work off to an AI agent and let it try and auto-resolve issues within the network to whatever degree a service provider may have an appetite to allow that kind of level of automation to go on. And then that will, again, move on to another stage there. So that will then allow us to kind of close that loop. So if we are seeing an issue and then we hand something off to the AI and it deals with that issue, using the tools that we've already got, we can check whether that issue has actually been resolved and whether that action was effective. And again, this can provide other kind of feedback loops in terms of what the AI should do in future in reaction to seeing any particular issues within a network. Okay, so that's probably enough slides. I'll jump in and show you some screens and show you what this stuff actually looks like in practice. Okay, so hopefully just showing up on screen now, you'll begin to see an ESRI dashboard. So this is a system, well, a front end that we've been working on directly with ESRI, using all of that data that we can provide to the ESRI platform, and then tie that in with the geographic capabilities of ESRI, and also then begin overlaying all of this other data that may be of use. So looking around this dashboard, we can see on the left-hand side here, we have information about the ONTs. So in this case, we're looking at a kind of typical PON fiber network with, as we can see there, around 44,000 devices connected to it. And within this side, we can begin to see kind of key stats from the device. So we can see things like the actual light level on the unit, see how well those are performing. These are all thresholded within the system, so we can put in industry norms of what is good or bad performance for these things and do things like color coding based on that as well. We can see here just sort of what our average light level is. I'm at a kind of full zoom on this particular map. So this is taking in all of the particular devices, but as I start zooming in, as I start moving around, we'll see this filter down to the specific areas that I'm looking at. And then on the right-hand side, we've got all of the OLT information here. So this is all of the kind of upstream core network devices that all of our ONTs are connected to. And actually, as I'm zoomed all the way out right now, we can see on the map all of these different colored markers, which represent the different OLTs. And we can see color coding of those OLTs right now. So if I just select one of these, I'll start to see the info for it. So I get the info panel here. I can see what the average temperature of that particular node is based on all the different ports that are connected. So it's doing certain averaging and aggregation of information that's being fed into the system. And we can see for the detail on the the pond side here, so the actual OLT side, again, we've got all the kind of temperature information, as well as a few other kind of key statistics, again, light levels, transmit power, things like that as well. And these all come with symbology that is matched to what we see in the map. So again, you can see it probably best here on this this gauge, where going from cold ports that are probably not of concern through to things that may be a bit overloaded, getting to the hot side. These all match up, all of this symbology here. So the color coding that I can see for these on the map aligns with what we can see on this particular marker here as well. Now, as I start zooming in here, we're going to start seeing more and more information actually populate in. So as I get to different zoom levels, it's going to start providing greater kind of context about what's going on. So if I have a look here, we'll see we're starting to get a lot more markers appear on the map. So these are all of our individual premises and the ONTs that are contained within them. Let me just go and select one of these so we can have a quick look at the data. So again, we get kind of an overlay for each one. There is additional contextual information that we can add, anything that we can go out and query from the devices based on the kind of NETCONF and gNMI stuff that I was mentioning at the start. We can pull all of that information back and then visualize any of that within these panels. You'll see, again, things are kind of following the color coding here, right? So the power level on this one is particularly poor. It would be here. What this is doing is averaging all of the nodes that I have on screen. So I've got like 1,200 right now, and this is the average of those. But this particular one I picked out because it was sort of a bright red marker on the map, and we can see exactly why with the RX power level here. Now, as well as the actual data that we're providing about these devices, this is being tied together with other information within the ESRI system as well. So if I have a look here, I can see the different layers that are actually layered into this map right now. So we can see things like the 811 information. So that was the construction data about where holes are being dug in the ground in this particular area right now. And we also have this communication network layer here. So this is actually the fiber map that was created in ESRI prior to any of this data that we're providing going into the system. And that provides all of these features that you see in terms of things like the actual fiber that's laid out here. If I can select one. Yeah, so this will give us all of like the fiber distribution information. Again, this is not data we're necessarily providing through the exports, but this is existing ESRI data that can be tied with the data that we're providing or overlaid to provide any additional context. ESRI themselves have a very wide range of standard overlays. So if you wanted to pull in things like weather events, power outages, really any kind of geospatial information that's available and collected, or your own proprietary layers as well, all of these things can be tied together and overlaid to, again, give that context, give that more service assurance view of what's going on within a particular network. The same is also true for all of these different areas that you see on the map. So these represent different service territories. So we can see our particular telco here and the particular area that we're looking at. And again, it's going to give you aggregation and contextual information for that specific service area as well as the network as a whole. So we can see how many ONTs we have in this particular location, how many OLTs are feeding them, and how well the things are performing on average in that particular location. One final thing just to touch on in the ESRI map is the alerting. So based on the information that we're providing in here, the ESRI system can include alerts. Just give this one a second to load in. In this particular case, we have one neighborhood with an outage. So selecting the alarm mode will highlight and zoom in on any faulty devices that are having issues. In this case, we can see the particular fiber that is running to this area, so we can have a look for any issues along the way. if I enable the 811 layer here, what we can actually see is there was some construction work going on here, and this is then the probable cause of our issue. Why that particular neighborhood is offline is because this company is doing some trench digging in this particular area and has probably cut that particular cable. So that's why that is offline. And again, this is the sort of enriched information that we can provide within the ESRI view to really understand not just what is happening, but also why it is happening and what may be needed to address it. Okay, I'm just going to move on to one last screen before we wrap up here. So let me just jump across. So just to give a bit more information on the pieces we've been developing internally. So again, we've been working on our own kind of network analysis tools. This is something that, again, as per the roadmap, we'll be looking to provide this kind of data to ESRI or any other third parties that we integrate to for these kind of service assurance use cases. What this is doing is monitoring networks that we're collecting data on. This can be, again, any type of network. We just need to get that into a particular data store, which again is very sort of standard practice for this data, and a lot of things out of the box will provide data directly into that database. And once it's there, we can then do our own sort of analysis of what's going on. So if I have a look at one of these networks, let me grab this one here. What the system's doing is trying to identify issues. So in this case, we can see this network has certain alerting going on. So what this is doing is pulling all the kind of alert information that we're collecting to see any kind of live issues that might be happening. And as I scroll through here, it's going to give a prioritized list of concerns about that particular network. So again, in this case, this one's looking at the actual performance data that we're collecting. We can see that in this case, memory is degrading on a certain number of things within this network, so the users can be warned about that, and they have kind of actions here that they can jump to go and investigate those. These will work for a wide range of different use cases, so be it kind of alerting, the kind of raw data that we're getting about performance, so are things below acceptable levels, and we'll also be looking for any cases of degradation as well, so where something was performing well but is starting to drop off from that performance level, and look for patterns in those. If I jump through to have a quick look at one of these issues and what it actually looks like in the system, what it's going to do is build out a graph of all the impacted items within that network. So we can see here we've got a certain number of kind of top level items. These are rolling up details from the different nodes underneath, and we can see things like their performance levels, how much things are improving or dropping off for various different metrics that we can collect, as well as pulling in any of that alert information. But critically, when a user gets to this view, it's going to be focused on whatever investigation that they've launched into, rather than just dropping them into the entire network. This will be kind of focused on the particular items that need addressing. But the user within here can also just go in if they want to just have a sort of general explore of a network and see how it's performing. Just change view here. So in this case, much like the data, this is the same data set essentially that we were looking at in the ESRI side. We're bringing through all those different metrics, showing their performance in here. We're able to move between any different metrics that we're looking to monitor and see how different things are performing. And again, things are getting flagged by whether they have alerts against them or they're degrading performance. And again, that's all the information that's getting fed back to our own analysis to look for any concerns or any issues within the network that need addressing. And it will also point out any sort of upstream concerns where one problem item may be affecting a lot of downstream items. So very kind of key again in any sort of network context. But yeah, that was a quick tour of what we've been working on for service assurance. I'll just open it up for any questions before we finish up today.